We're live. We're live. Uh, I'm gonna take a minute and get some water, but I've got the stream turned on so people can start joining in. Back in a minute. Hello, it's me, I'm back. How's it going? Math 142. You guys, I just taught 122 for like an hour and a half, and my stylus worked the whole time. I fixed my stylus. You guys, I'm so happy. How's it going? Anybody watching? How many viewers do I got? Did that? I have one viewer, and it's me. So nobody's watching. That's cool. Let's talk about what were we doing? We're doing integrals. We talked about integration by parts. Oh, we talked about trig tricks. I still need to go back and add some of those even powers stuff into there. Yeah. Anyone got any homework questions? That's right, there's nobody watching. Don't bother asking, Andy. Where did I leave my trig tricks sheets? Is that this? And I printed, like, left the screen to go print the junk off. Oh yeah, that's the stuff that came out. No, it's not that. Well, I guess I'm, oh, there it is, okay. We did that, we did that, we did that. I guess we're done with the trig concepts thing. Still don't know how to do e to the x over x. I'm not sure you can do that one. Okay, we're done with parts. I think our next topic is trig substitution. Oh man, am I out of... I should have gone through these notes before I started the stream. This sucks. I know I got this right here somewhere. All right, let me just grab an example. Here we go. We're getting started with trig substitutions, and before I tell you what a trig substitution is, I'm just going to do a trig substitution so you can see how powerful it is. Trig substitutions. Here is an example. Suppose I want to integrate the square root of 9 minus x squared over x squared dx. These kind of square root things are generally a huge hassle. Like, it's really hard to get stuff out of the square root. If there is, I really want to do the substitution, like u equals 9 minus x squared. I can try that out. It doesn't do as good as you want it to be. You just sort of move the grossness from the top to the bottom. This integral's rough. The way I'm going to do it is doing a weird substitution that comes out of nowhere. I'm going to do the substitution x equals 3 sine theta. We're going to come back afterwards and say, why would you try x equals 3 sine theta? But before we say, like, the strategy, let's just try executing it once and see why it's a good idea. When x equals 3 sine theta, this becomes, oh, I should do dx. Dx is going to be 3 cosine theta d theta. My integral turns into the integral of square root of 9 minus x squared is 9 sine squared theta over x squared is 9 sine squared theta. Dx is 3 cosine theta d theta. Why was this helpful? Look at what's going on inside that square root. There's a 9 I can factor out. That's the square root of 9 times 1 minus sine squared theta. Oh wait, I know something about 1 minus sine squared theta. The square root of 1 minus sine squared theta is cosine squared theta. Ooh. Okay. Now we're going to do something that's always bugged me. Hey, what's the square root of x squared? How does that simplify? What? What's that? You say it's x? It's not actually x. It's the absolute value of x. If you take a number as square it and then square root it, you're always going to end up with the positive version of a number. This can be nice to have a simple way of writing the absolute value of x. You probably never learned a derivative formula for the absolute value of x, but if you rewrite it like this, you can use the chain rule and take the derivative all of a sudden. So this thing on top, this square root of 9 cosine squared x, should technically be 3 is the square root of 9. Absolute value of cosine theta over 9 sine squared theta times 3 cosine theta. But the way these trig substitutions work out, you don't have to deal with the absolute values. You just put cosine theta and everything takes care of itself. At the end, the thing in our answer will end up being a thing where the thing was positive anyway. You don't have to worry about it. Like the issue is that when you have x equals 3 cosine 3 sine theta, what your substitution really is sine theta equals x over 3. So theta is sine inverse of x over 3. If you think about the graph of sine inverse and what it's doing on this region, this is only going to be defined from -3 to 3. Sine looks like this. Sine inverse is going to look like this. On this region, cosine is positive, is the thing that happens. If I had used cosine, it might be gross. Anyway, the moral of the story is, hey, when you take the square root of x squared, you don't just get x, you get an absolute value. But in these trig substitution problems, you can ignore the absolute values because they take care of themselves at the end. So I'm going to say this is just cosine theta, which is probably the thing you would have said it was if I hadn't butted in to make a big deal about it isn't. I have 3 times 3 divided by 9, all cancels. I'm integrating cosine squared theta over sine squared theta, d theta. I'm integrating cotangent squared theta, d theta. How do I integrate that? Well, good news, everyone. We just had a whole section on how to deal with trigonometric integrals. This is a thing that we know how to do. If you're watching later, pause it and see if you can remember the trick for this. The trick is to use the trigonometric identity, and it turns into something easy. Sine squared plus cosine squared is 1. I need to divide everything by sine squared. I get 1 plus cotangent squared equals cosecant squared. So cotangent squared is cosecant squared theta minus 1. The integral of cosecant squared is the derivative of cotangent, but it's negative. So I get negative cotangent theta minus theta plus c. It's really tempting to put a box around that, but that's not our answer. We solved the problem in English, but we got to translate our answer back into French. We need to go back and say what theta was. What was theta? We had x was 3 sine theta was our original thing. So x over 3 is sine theta. So theta should be arcsine x over 3. Excuse me. I gotta remember to mute when I sniffle. Theta is sine inverse x over 3. I can just plug that in everywhere and get a technically correct answer. Cotangent of sine inverse of x over 3 minus sine inverse of x over 3 plus a constant. But it's generally considered bad form. Don't do that. This simplifies. You had a section in some class on trig that was about how do you simplify junk like that. And I think the way you do it is you write a reference triangle. Instead of ever writing this down, to find cotangent theta, you go to here and you write a reference triangle. I want to imagine a triangle, a right triangle, like SOHCAHTOA sense, where sine theta, sine is opposite over hypotenuse, needs to be x over 3, so I'm going to rig up my triangle so that opposite over hypotenuse is x over 3. If this side is x and that side is 3, then this side, Pythagorean theorem, will be the square root of 9 minus x squared. X squared plus this squared equals 9. Solve for that, you get square root 9 minus x squared. In general, when you're doing this, that third side should probably be a thing that you saw in the original problem, and it is. Cool. So to tell you what cotangent theta is, that's a thing I can read from this reference triangle. Tangent is opposite over adjacent, so cotangent is adjacent over opposite. So cotangent theta, so negative cotangent theta minus theta plus c becomes negative. Cotangent is adjacent over opposite, that's root 9 minus x squared over x is cotangent theta. Theta itself, there's nothing we can do about the arc sine. We write that as sine inverse or arc sine of x over 3. I don't really care about the difference between sine inverse and arc sine. I'll use both words interchangeably. Some places see them as different. I do not. We got an answer. So, part 1 of this example is, hey, doing this trig thing changed it from something that had a square root in it to something that didn't have a square root in it. And the way it did that is by taking a stuff inside of the square root, changed a trig identity, combined this from two things into one thing, if you use the correct trig identity. 2 is to turn our answer back, we need to know how to do this stupid reference triangle thing, which sucks, but you got to know how to do it. That's an execution of a trig substitution. The moral of the story, to do a trig substitution, is if I see an integral involving a squared minus x squared, or x squared plus a squared, or x squared minus a squared, I might try for a squared minus x squared, try x equals a sine theta. For x squared plus x squared, I might try x equals a tangent theta. And for x squared minus a squared, I might try x equals a secant theta. These are the thing that when you stuff it in will give you the correct trig substitution. And you can verify that separately from the integral. A squared minus x squared, if this is x, then a squared minus x squared is a squared minus a squared sine squared is a squared 1 minus sine squared is a squared cosine squared. If I have x equals a tangent theta, then x squared plus a squared is a squared tangent squared plus a squared. That's a squared tangent squared plus 1. That's a squared secant squared. The plus goes away. The plus goes away. This one will lead to secant squared minus 1, which will turn into tangent squared. In all these situations, this sum or difference of something with an x squared goes from being two terms to being one term. That new term has trig in it, which is worse, but it's no longer a plus, which is usually better. Let's try this out. Let's do the integral of 1 over the square root of 1 minus x squared. What form do I see? I see this form with a is 1. So I should try x equals 1 sine theta. This will become the integral of 1 over square root 1 minus sine squared theta. Dx, I still need to convert that, is going to be cosine theta d theta. Cosine theta d theta. What's square root 1 minus sine squared? That's the square root of cosine squared. My brain is freaking out at me that there's an absolute value here, but we ignore the absolute value. The cosine and cosines cancel. I'm just integrating 1. What's the integral of 1? This is the place where a student says it's x, and I say, no, it's theta, because it's an integral d theta. But now what was theta? X was sine theta, so theta is sine inverse x. So I get sine inverse x. Let's see. And here's the place where you go, oh crap, that's the derivative of sine inverse. I totally knew exactly the function this is a derivative of. Well, I have a way of doing that even if I don't remember that. Let's immediately do one where the numbers get grosser. If I have the integral of x cubed over the square root of 9x squared minus 4. Let's go back and look at what we had written down as our rules. Let me copy this onto a new page. This doesn't quite fit what we said with the rules. If it's going to match one of these three things, so I just wrote these rules down and I'm already making them grosser. The x squared, I have 9x squared minus 4. Ignoring the 9 for a second, this is x squared minus something. This should be this basic form, right? So I'm expecting to use something with a secant. The thing that's a pain, though, is that I don't just have x squared there. I have 9x squared there. All of these have a second-level grosser version. I never really memorized the second-level grosser version, because I'll see how you can get away without that. If you have a constant in front of an x squared, which I'm going to write as b squared, if it's not a perfect square, then b is the square root of whatever you do see there. This isn't a squared minus x squared anymore. This is a squared minus something squared, and my something is bx. What I'm basically doing is the same substitution, but instead of just saying x is this, I want to say bx is this. The thing works the exact same way, except I don't have an x in there. This isn't x that's being squared minus 4. This is 3x being squared minus 4. So if I'm just remembering the substitution that way, I can do it the same way, except instead of it being 2 secant theta being x, it needs to be 3x that's 2 secant theta. If you want to, you can solve this for x, but you don't particularly gain any value from that. If you're comfortable doing the d's with the 3 on both sides, which you can, the derivative of this is 3 dx. The derivative of this is, what's the derivative of secant? Secant tangent. 2 secant theta tangent theta d theta. This works just fine. And I'm comfortable putting that 3 there as long as I can pop out a 1/3 to cancel it. So I jumped into the gross version of a trig substitution right away. I wish I had a 3 dx. I'll put a 1/3 to fix it. What does this turn into? If 3x is 2 secant theta, then 9x squared minus 4 is that squared minus 4. 4 secant squared theta minus 4. That's 4 secant squared theta minus 1. That's 4 tangent squared theta. The thing inside the square root becomes 4 tangent squared theta. You can do all of this inside the square root, but it's like gross, and you don't want to have to write the integral 4 times to do this little computation. So I usually do this off to the side. I get equals 1/3. X cubed becomes 2/3 secant theta cubed over. That square root becomes the square root of 4 tangent squared theta. That 3 dx becomes 2 secant theta tangent theta d theta. What do I get? 2/3 cubed is 8 over 27. I'll pull that out. I'll smush it together with the extra 1/3 soon. I got secant cubed. I got 2 tangent theta on bottom, technically absolute value tangent, the absolute value won't matter. 2 secant theta, tangent theta, d theta. This thing on top is secant cubed theta. And I did the 2/3 part. Have I got everything? Yeah, I think this is everything. These 2's cancel. One of the tangents cancels. I'm left with secant to the 4th. I got 8/81 integral secant to the 4th theta, d theta. It's really surprising that the correct substitution, like this integral we started with, x cubed over square root 9x squared minus 4, it's like sort of a joke that you do one clever substitution and it turns into the integral of secant to the 4th. It's not obvious that this problem is going to be any easier, but we've done enough of the trig problems to feel pretty confident with almost any power of sines, cosines, secants, tangents. Any product of sines and cosines is basically something we can integrate if we understand all those rules. Some of them are hard, some of them are not that hard. Secant cubed is usually the hardest one. The thing that's hard is an odd number of secants and an even number of tangents. This has an even number of secants, so this is supposed to be one of the easy ones. Why is it one of the easy ones? Well, when I have an even number of secants, I can pull out 2 secants. 8/81 integral of, I'm going to pull out 2 of the secants, secant squared theta d theta, and I'm left with another secant squared here. The reason I pulled that off to the side is this is all going to be my dt for the correct u substitution. What's the choice of u that makes this the derivative? It should be u equals tangent theta. We'll make du equal secant theta d theta. And because I had an even number of secants, I have this thing is secant squared. Secant squared can turn into a tangent squared. What is secant squared? Secant squared is tangent squared plus 1, right? So this turns into, I'm out of space. Why am I so bad at this? Actually let's just, I got this whole lasso thing. Take the space you need, Andy. Be a good teacher. Copy. Paste. I got 8/81. Integral of tangent squared plus 1 becomes u squared plus 1. Secant squared theta d theta becomes du. I know how to do that integral. It's 1/3 u cubed plus u. I guess there's no reason not to simplify this. This is 8/243 u cubed plus 8/81 u. Sorry, I gotta remember to mute when I do that. What was u? U was tangent theta. 8/243 tangent cubed theta plus 8/81 tangent theta plus c. But what was theta? Where there were 2 substitutions that happened. First a trig substitution, then a u substitution. We've undone one of the substitutions, we still have to undo the other. What was our rule for the first substitution? Our first rule was 3x equals 2 secant theta. 2 secant theta. Again, I want to work this out with a reference triangle. If 3x is 2 secant theta, then 3x/2 equals secant theta. If the SOHCAHTOA you have in your head does secant, then go for it right away. I always have to convert this to cosine. Secant's the reciprocal of cosine. Let's take a reciprocal of both sides. Cosine theta is 2/3x. Now I'm ready for my reference triangle. So Katoa, the cosine is adjacent over hypotenuse. Adjacent over hypotenuse is 2 over 3x. If this is 2 and this is 3x and it's a right triangle, so this squared plus this squared equals this squared, then this thing is going to be the square root of that squared minus that squared. It's going to be 9x squared minus 4. If I'm doing it right, probably the original problem had a root 9x squared minus 4 in it. Did it? It did. That's a good sign. So, yeah, there's my theta. What's tangent theta? Tangent theta is opposite over adjacent. Opposite over adjacent is, I got 8 over 243. Opposite over adjacent is root 9x squared minus 4 over 2, all cubed. 8 over 81 root 9x squared minus 4 over 2. These constants simplify enough that I think it's probably worth doing. This 2 is cubed, will cancel with that 8. I get 9x squared minus 4 to the 3 halves over 243. One of these 2's cancel, I get 4 root 9x squared minus 4 over 81. Plus a constant. Gross! There's our answer. I wouldn't do it on every problem, but once in a while, I recommend taking a derivative of this answer and seeing how on earth does it miraculously simplify to be that. I think it makes you smarter to do that some. Let's keep going. Let's try. I should point out, I say that when you see this, you should try this substitution, and you might try it at any time, but it's especially good if you see it inside a square root. The thing about this thing inside a square root, it sort of shows up in applications a lot, square roots of stuff like this. But when you have it inside a square root, the thing you're going to end up with after you do the simplification is always a perfect square. So the square root goes away, and it's great. Like, it not only turns the sum into a product, the product is a square, and it'll kill a square root that was outside there. So those are the best possible situations for a trig substitution. Let's integrate x square root 4 plus x squared dx. Which version of this is this? This is I have a squared minus x squared. I have x squared plus a squared. I have x squared minus a squared. I don't have an a squared plus x squared. Wait a minute, a works the same. This is x squared plus a squared. Plus doesn't care about the order. 4 plus x squared is the same as x squared plus 4. The thing to do is the tangent. You guys with me? Can anyone hear me? Send me a text if you can see me. I just got a message that my something went wonky with the stream. Text if you can see me. I just got a message that my something went wonky with the stream. Is my internet bad down here? Internet seems fine. Ooh. Let me check my phone one more time. Hello. Hello. Okay. I'm just going to assume I'm still up. This is well set up for a substitution for this odd number of tangents. It's telling me I should pull off a secant tangent. That likes the substitution u equals secant theta, because then du will be that secant theta tangent theta d theta. This one I don't even have to do any trig. I got equals 8. No, cancel it. Equals 8 integral secant squared theta times secant theta tangent theta d theta. This whole thing becomes du. This is u squared. I get 8 integral u squared du. I know the integral of u squared. It's 8/3 u cubed. What was u? This is 8/3 u was secant theta. 8/3 secant theta cubed plus c. Don't put a box around this, because there is still one substitution left. What is secant theta? Well, x was 2 tangent theta. Tangent theta is x over 2. Hey, someone texted me. Oh. Yes, I should mute my phone. So I can, yeah. Tangent theta is x over 2. I draw a reference triangle. Tangent is opposite over adjacent is x over 2, so this thing is the square root of 4 plus x squared. So secant theta is the reciprocal of cosine. Cosine is adjacent over hypotenuse, is 2 over root 4 plus x squared. Secant is the reciprocal of that. I got 8/3 root 4 plus x squared over 2 cubed. 2 cubed cancels with the 8. I got 1/3 4 plus x squared square root cubed is a power of 3 halves. Cool. Cool. After you do a problem like this, when the thing goes really simply, what went really simply? I guess the integral happened very, very easy. That's sometimes a sign that there was a much easier way to do this. If I look at the original problem, integral of x root 4 plus x squared. After doing a trig substitution, I am always kicking myself to say, damn it, I could have just done the u substitution, u equals 4 plus x squared, because du is 2x dx. There's an x right out there. Oh man, that would have been just half integral root u du. I can do that. That's integral of u to the 1/2 is u to the 3/2, 2/3, 1/2, you get 1/3 u to the 3/2. Yeah, that's the same answer. This was a really simple u substitution. Just because you are given a hammer doesn't mean everything you see is a nail. Trig substitution works. It's worth taking a second and seeing, is there an easier way to do this? Because often there is. So that's the trick of trig substitution. I should do some more examples. I want to try and make them a little easier. Let's try this. Let's find the area of an ellipse. I don't know if you guys had a section on... When I was in I went to high school in the 90s, and in the 90s, if you were a math kid, then one of the sections that you saw was on conic sections. That was a topic that they would cover in high school. And one of those, I don't know if they cover this anymore. I think they don't. I haven't heard of a student who knew what a conic section was, but you would learn the equation of an ellipse. An ellipse has a minor axis and a major axis. If the short axis has a distance of a, and the longer axis has a distance of b, then the equation of this thing is, what is it? It's x squared over b squared plus y squared over a squared is 1. This is the way to write the equation of an ellipse, or this is the way they wrote it in my 10th grade, what was it, Algebra 2? It feels weird calling this Algebra 2. It doesn't feel like algebra to memorize equations of ellipses. Anyway, that's an equation of an ellipse. If you have a circle, the area of a circle is pi r squared. That's with a distance of r here and r here. And I know that for a square that's r by r, the area would be r squared. And it's pretty reasonable to make the guess that if the area of a circle is pi r squared, then the area of this wonky circle might be pi times this width, pi ab. But I guess the thing about a circle is it doesn't matter which direction you go in. Maybe it should have been, if I do this way and this way, I'll get r squared. Maybe the correct thing for an ellipse would be this direction and this direction. Maybe there's a chance you get the same thing no matter what. I don't know. We're going to find the area of the ellipse, though. This equation is, well, I wrote it this way. I think I have the a and b switched from what they normally are. But this equation does match with this graph, so we'll just go with this equation. I want a formula for that curve. If I take this thing and solve it for y, I get y squared over a squared equals 1 minus x squared over b squared. So y over a is plus or minus the square root of 1 minus x squared over b squared. So y is plus or minus a square root 1 minus x squared over b squared. I'm going to just find this area, which is 1/4 of the ellipse. So the area that I want is 4 times the area of that section, which is the integral from 0 to b, this is 0, this is b, of this function, of a square root 1 minus x squared over b squared. I'm going to use the positive square root because I'm using the part of the curve that's above the x-axis. The negative will be that area, or it'll be negative that area or something. There's the integral I want to do. Hey, perfect, this is a trig substitution, so that's like exactly what I want to show off. What trig substitution should I do? This is 1 over x squared version. When I see 1 minus x squared, I want to do x equals sine theta. I don't have x squared, I have x over b squared, so I probably want x over b to be sine theta. So that's the substitution I'm going to do. I want 4 integral 0 to b, a root 1 minus x over b squared. I'm doing the substitution, x over b equals sine theta. Just like with a trig substitution is a version of a substitution. I guess I never said that up front. This is just a particularly tricky substitution, but it's still just a substitution. And just like we talked about on the first day, when I do a substitution, I need to change the bounds of integration. This is x equals 0 to x equals b. This is going to turn into, if x is 0, what's theta? Sine theta should equal 0. Well, one of the places sine theta equals 0 is at 0, so 0 will work. What happens when x is b? When x is b, I get sine theta is b over b is 1, so I want a place where sine theta equals 1. That's at pi over 2 is a place where that happens. So we'll go from 0 to pi over 2. The a can come out. What's this thing inside the square root? Well, if the square root of 1 minus x over b, and x over b is sine theta squared. What's dx? Well, dx over b is cosine theta d theta, so x is b cosine theta d theta. I got 1 minus sine squared. So I got 4ab integral 0 to pi over 2 square root of cosine squared theta cosine theta d theta. Here's one of these places where there should be an absolute value there. I know in my guts the square root of cosine squared isn't just cosine, so how come I don't have to put the absolute value? This example comes close to showing why you don't actually need that absolute value. It's because I care about what cosine is doing between 0 and pi over 2. What does cosine look like between 0 and pi over 2? Why, it's positive. So the absolute value isn't going to do anything. If I let these x's go negative, I would have this part of cosine. And that region is the entire region you could even possibly look at the curve on. The square root will be the square root of a negative if you go any further. So because sine is using all of its values, sine is doing everything you want it to do, going from -1 to +1 in a region where cosine is positive, the square root doesn't matter. It ends up being just cosine because cosine is positive there. There's like one situation where it does matter, and that's the place where you get the absolute value in, what is it, the derivative of secant inverse or something. It doesn't happen for sine and tangent, and we don't really worry too much. I'm not going to deal with the absolute value that could be there for secant. I end up needing what's the integral from 0 to pi over 2 of cosine squared theta d theta. How do you integrate cosine squared theta? This is where you use the trig identity, the double angle one. This is 1 plus cosine 2 theta over 2. What's the integral of a half? It's theta over 2. What's the integral of cosine 2 theta over 2? The integral of cosine is sine. Divide by an extra 2, I get 1/4 sine 2 theta. Evaluate that from 0 to pi over 2. I got 4ab, plug in pi over 2, this is pi over 4, plus, plug in pi over 2, 1/4 sine pi over 2 times 2 pi is, pi over 2 pi over 2 is pi, is what I'm trying to do, minus plug in 0, you get 0, you get 0. Sine pi is 0, so the pi over 4 is the only part that matters. So 4ab pi over 4 is pi ab. Just like we would have guessed, the pi r squared becomes a pi ab. Cool. We got the area of an ellipse. That's an excuse to do a trig substitution. Let's do... we got to do one of these. Alright, this is going to be rough. I'll give you a heads up. Let's do the integral of the square root of... Let's do one slightly nicer version. Let's do x squared minus 4x. If I look at my list of trig substitutions to try, none of them matches this, because those are all a constant. Where is my list? Those are all a constant and a constant multiple of an x squared, and none of them has an x on it. So what's going on? Why do I have this x thing here? The idea is you can put any quadratic inside of a square root, and it's the type of thing that a trig substitution is good at, because any quadratic can be made into the correct form by completing the square. Gross. Remember completing the square? That's a thing you gotta remember how to do now, all of a sudden. X squared minus 4x. what is the blank that makes this a perfect square? Well, this is the thing where you cut that in half and square it. Half of -4 is -2, square that is 4. I kind of wish I had a +4 here. I don't get to put a +4 just because I want one. I'm going to put +4 and -4. This I can rewrite as the integral of the square root of x squared minus 4x plus 4 minus 4 dx. This thing is now a perfect square. It's the integral of, that is x minus 2 squared minus 4. This now looks like the form of a situation where I want to use a trig substitution. It's not x squared minus 4, it's this squared minus 4. That's okay. The thing I would want is, if I had u squared minus 4, I would want u to be, like, you can do a u substitution, let u equal x minus 2, if you don't like doing this big chunky step here. But if you don't want to do that, then the thing that is u is x minus 2 would want to be 2 secant theta for this substitution. I'm going to let x minus 2 be 2 secant theta. That's going to be the write-up for my substitution. I can move the +2 to the other side if I really want to, but this is a fine thing to take the d of on both sides. Derivative of this is 1 dx equals the derivative of this is 2 secant theta tangent theta d theta. So dx becomes 2 secant theta tangent theta d theta. Okay. And what is x squared minus 2 squared minus 4? X minus 2 squared minus 4 becomes, that squared is 4 secant squared theta minus 4. That's 4 secant squared theta minus 1. Secant squared minus 1 is, yes, is tangent squared. So this integral becomes integral of square root of, we just said this mess was 4 tangent squared theta. We just said dx was 2 secant theta tangent theta d theta. 2 times 2 is 4 integral secant theta tangent squared theta d theta. We got something. That's an odd number of secants and an even number of tangents. Gross, this is the hard one. Gross, gross, gross. Well, let's do it. How do I do this? You start with parts. I'm going to push the 4 inside the integral. This is 4 secant theta tangent theta. I'm grouping them together because that's something I know how to integrate. That's going to be my dv for the parts. So tangent theta is going to be the other part for the other part of the parts. I'm asking what's u in dv. dv needs to be something I can integrate. The thing there I can integrate is 4 secant theta tangent theta. I could leave the 4 outside, but I don't want to have to distribute the 4 into the integration by parts rule. The integral by parts rule is something minus something, and the 4 needs to hit both, and I'm going to mess it up if I need to remember to put the 4 on both, so pushing the 4 into the integral by parts hides it somewhere where I'm not going to lose track of it. The integral of 4 secant tangent is 4 secant. No d theta anymore. There was a d theta up here. What's u? U is the other thing, is tangent theta. What's du? du is secant squared theta, d theta. Integral by parts formula. I want uv minus integral v du. U times v makes 4 secant theta tangent theta d theta. Not d theta anymore. There's no d thetas. Secant theta tangent theta, that's it, with a 4. Minus the integral of v du is 4 secant cubed theta d theta. We turned secant tangent squared to secant cubed. When we integrated secant cubed, we turned it into secant tangent squared. Then we used the trig identity to turn the tangent squared back into a secant squared, so we had secant cubed again. Our goal is to get the original integral back. I want to pull out the secant squared. and convert this back into a tangent squared. What is secant squared? Secant squared is 1 plus tangent squared. You get 4 secant theta times 1 plus tangent squared theta. I can't tell you how happy I am my stylus is just working the whole time. It is amazing. I can't believe I didn't Google that before now. I have stuff minus the integral of 4 secant theta d theta. That's the first part of the integral. Minus the integral of 4 secant theta tangent squared theta d theta, which was the original integral, right? 4 secant tangent squared, 4 secant tangent squared. Awesome. If I move this, so this original integral equals this, minus the original integral again. Move this to the other side, I get 2 times the original integral equals 4 secant theta tangent theta minus 4, what's the integral of secant? This is the situation where you multiply the top and bottom by secant plus tangent. I don't want to have to do this every time. I've got it memorized. The integral of secant is natural log absolute value secant plus tangent. I guess there's a plus c at this point. So the integral I want is half of that. That makes the 4's turn into 2's. Great. So the integral I wanted is 2 secant theta tangent theta minus 2 natural log absolute values secant theta plus tangent theta. But I still got to translate the problem back. What was my original setup? It was x minus 2 equals 2 secant theta. I got to do a reference triangle to get my answer. If x minus 2 is 2 secant theta, x minus 2 over 2 equals secant theta, so cosine theta is 2 over x minus 2, so my reference triangle will have adjacent over hypotenuse is 2 over x minus 2, so this last side is the square root of that squared minus that squared. I should have given myself more space. 2x minus 2, this is the square root of x minus 2 squared minus 2 squared. That's x squared minus 4x plus 4 minus 4. This is, triangle has 2, x minus 2, square root of x squared minus 4x. Ugh. Okay, this is what I gotta convert. All I need is what's secant and what's tangent. Secant I already knew was x minus 2 over 2. What's tangent? Tangent theta is opposite over adjacent is root x squared minus 4x over 2. So the integral that I wanted is 2. Secant theta is x minus 2 over 2. Tangent theta is square root x squared minus 4x over 2. Minus 2 natural log absolute value secant theta x minus 2 over 2 plus tangent theta square root x squared minus 4x over 2. I guess this cancels. I get x minus 2 root x squared minus 4x all over 2 minus 2 natural log absolute value. I guess I'll combine that into a single fraction. X minus 2 plus root x squared minus 4x. Man, what's a constant? When you do the moving the integral to the other side, you usually don't end up with the plus c unless you remember to add it back. Boy, that's rough. I feel like saying I'll give you $5 if you take the derivative of this and see how it turns out to be square root x squared minus 4x. But I don't want to make a habit of giving $5 to every student. But it's worth a cookie at least. Man. So that's trig substitution. How are we doing for time? I guess time is an illusion. Man, I I don't know how to teach when I could just teach as long as I want. Like, this is just going online. Nobody's watching me right now. No one cares if I lecture for 6 hours. Do I lecture for 6 hours? I don't want to lecture. Let's just say I'm done. I'm done. That's trig substitution. That's as bad as it gets. Actually, it can get a little bit worse. Let me show you the start of a problem where it gets a little bit worse. The issue is the completing the square thing. If I had the integral of the square root of 5x squared, let's see, do I put it plus x? Let's put plus x minus 100. This is a gross one that doesn't look like it's set up for a trig substitution, but this thing is a quadratic. Anytime you have a quadratic, it's possible to complete the square and make it look like a thing that is set up for a trig substitution. The issue here is that the extra difficulty is now we have a 5 in front of the x squared, which is even worse. Here's what I'm going to do. The minus 100 is a constant. I'm going to pull that over. Also, I'm going to factor out that 5, because I want it out of the way. What do I get when I factor out that 5? I get x squared plus 1/5 x blank. This is the place where I want to complete the square. If you haven't done completing the square in a while, the idea is you want x plus a squared to be x squared plus 1/5 x plus something. When I FOIL that out, I'm going to get x squared plus 2ax plus a squared equals x squared plus 1/5 x plus blank. So if these are going to match up, then 2a needs to be 1/5. So a is half of that, is 1/10. A squared is the thing that goes here then. A needs to be 1 over 100. It adds up to take this number, cut it in half and square it, and that's what you want to be here to complete the square. I wish I had plus 1 over 100 there. I don't get to do that just because I love it. Like, I need to not change the expression. I'll put plus 1 over 100 minus over 100. That definitely hasn't changed the expression. Oh man, my stylus stopped working. Oh, nope, it wasn't my stylus. Man, that's the wrong time for the note to crash. I was right in the middle of junk. That was a really hard problem I was in the middle of. I don't suppose you remember what we were doing, do you? Yep, and threw away the whole dang problem. Can I even remember what it was? I think it was 5x squared minus x? I don't remember. I'll think it minus x plus 100. The idea is 5x squared minus x, move the plus 100 off to the other side. Factor the 5 out of here. Even though it doesn't factor easily, force it out. I get 1/5 x. Leave the blank. I look at this number, cut it in half, and square it. Half of it is 1/10. Square it is 1 over 100. Actually, when I cut it in half, it's negative 1/10, but when I square it, it's still plus 1 over 100 I wish I had here. I don't get to put the thing I wish I had just for free. I gotta cancel it. We get plus 1 over 100 minus 1 over 100. Now, these three things I like being there. X squared minus 1/5 x plus 100th. That's a perfect square. What are you doing here? Get out of here. When I pull this out of the parenthesis, the thing I gotta keep track of is it's getting hit by the 5 on the way out. Like I'm distributing the 5, basically, only into this part. I get 5, x squared minus 1/5 x plus 100th, minus 5 over 100 is 1 over 20, plus 100. I guess I want to combine these. What's 100 plus 1 over 20? That's 2001 over 20, I think. Common denominator is 20. Rewrite 100 as 2000 over 20. Yeah, so I get 2001 over 20. I get 5 times x minus 1/10 squared minus 2001 over 20. That's the thing I want to integrate the square root of. That's the original problem. So this is just completing the square on the stuff on the inside. This suggests to me so now, if I had x squared minus a squared, I would want to use x equals, what is it, a secant theta? Let's double check before I get too into this. Yeah. If I have x squared minus a squared, I want x to be a secant theta. What is it that is squared here? The thing that this is the square of is root 5 x minus 1/10. I want that to equal a secant theta. Well, this isn't obviously a perfect square, but it's definitely the square of something. The thing it's the square of is root 2001 over 20 secant theta. This is the trig substitution that will make that nice. I'm not actually going to go through the rest of this. Oh, not x minus 10, it was x minus 1/10. The dx version would be derivative of this is root 5 dx equals derivative of this is root 2001 over 20. Derivative of secant is secant theta tangent theta d theta. So this is the d version of that substitution. I'm not going to go through it. I don't think there's anything in the homework that's quite this bad, although you do have to deal with these gross square roots, but not all of them at a time in the homework. Yeah, I'm going to stop lecturing here. That was a rough one. Where were we? Do I have the homework posted? This is not the homework. I think you have everything. So the homework has a section labeled trig substitution. You're ready to do that stuff. Course content. Oh, I'm on course content. Homework. Here's the homework tab. Yeah, so you're ready to go through 31, is all the way through trig substitution. Next time, I think we're doing okay for time. I guess tomorrow, if you guys have any questions from the homework, I can do a questions from the homework lecture tomorrow. If I don't hear anything from you guys, I'm going to skip tomorrow. Monday we'll pick up with partial fractions. We're headed towards having an exam at the end of next week. I think I want to have the exam Friday 2 to 4. I will text you guys and ask if Friday 2 to 4 works. I'm going to do a synchronous exam, meaning you guys all have to sit and take the exam during the same 2 hours. And those 2 hours, I'm looking at Friday 2 to 4. If that doesn't work, let me know. Trig substitution, man. Okay, that's it. I'm signing off. How do I sign off? Here it is. End stream. It's ended.